All right, ladies and gentlemen, welcome to Maker Faire 2023. Let's give a round of applause for our... Ladies and gentlemen, students and teachers, esteemed guests, fellow makers, welcome to our highly anticipated 2023 SJND Maker Faire. I am honored to stand before you today as we celebrate the creative ingenuity and innovative spirit of our brilliant young minds today. First and foremost, I want to express my deepest gratitude to all the participants, teachers, and mentors who have worked tirelessly to make this event a reality. Your dedication and passion for nurturing the next generation of thinkers and creators are truly commendable. Today we gather here not just as spectators, but as a community of individuals who believe in the power of imagination, problem solving, and hands-on learning. This Maker Faire is a testament to the fact that ideas can come to life through the synergy of intellect, collaboration, and perseverance. Take a moment to appreciate the countless hours of brainstorming, designing, prototyping, and refining that have gone into each creation you see today. Behind every display, there is a stage of late nights spent tinkering, of failures turned into lessons, and unyielding determination that has shaped these exceptional projects. Beyond the immersive displays, this event serves a greater purpose. It serves as a platform to foster a culture of innovation to inspire young minds at SJND and beyond to think critically and solve problems creatively. It ignites the spark of curiosity that can set ablaze a passion for discovery. Today we celebrate the power of making. We celebrate the transformations of ideas into tangible realities. Let this Maker Faire be a reminder to the innovation has no bounds, and that the future is in the hands of those who dare to create it. Thank you for being a part of this incredible celebration of creativity and ingenuity. Together, let us embrace the spirit of making, inspire one another, and make way for a future that is driven by limitless possibilities. Thank you all for coming, and in the spirit of Maker Faire, thank you to ChatGPT for writing my opening speech in less time than it took me to speak it to you today. Welcome again to the 2023 SJND Maker Faire, and we'll go around it and have some exhibits going on. We have a raffle going on for a few of the prizes up here. We have a custom-made 2023 Maker Faire t-shirts along with a special drone, so designed by Christian Grunt over here. So now at this time, I'd like to invite Liz Taylor, the president of DOER Marine Operations, to give our keynote speech this afternoon.
Thanks so much. It's really great to be back at SJND. I've had a couple of kids come through here, and many interns have come over to our company and work for us over at DOER Marine, both when we were over at Alameda Marina and now out on the west end at Alameda Point. So I just wanted to give a shout out to some of the great buildings that we have here in Alameda that really allow for the kind of innovation and making of things. We're really lucky to have those kinds of spaces, and they're really very critical for people to be able to get hands-on with things. We've lost a lot of barns and workshops and places where growing up I used to be able to tinker and mess around with things. Having a grandfather that was an electrical engineer and grandmother that was a nurse, I had the great combination of fixing animals that were brought to us, as well as tinkering with a lot of things and innovating. So always remain curious. So at DOER Marine, we build tools and technology for exploring the ocean. This is a remotely operated vehicle that we built for a mega yacht for an owner that was really curious about what was going on underneath the boat. And so we were able to build this really interesting 3,000-meter ROV. If you look on the front of the vehicle, you'll see it's got a couple of folded up arms, but when the vehicle's deployed, those arms open way up to a 12-foot spread with individual lights that can pan, tilt, and color correct. It also has a hydraulic color correction disc that comes out to get the best possible video for this machine. So this was used in the recovery of the Belle from the HMS Hood. It went out to Bikini Atoll and did some work out there. It's been used all around the world to help the owner get really great video, but also to contribute to science. We took it out on a whale fall down at Scripps Oceanographic Institution, and they were able to go down and take some samples from that dead whale skeleton that Richard Branson sank the whale, and then the owner of this vehicle wanted to go check it out. So we were able to get some scientists on board, and they found some new species of bone-eating worms, and they also were able to recover some bacteria from the carcass that turned out in the laboratory to be effective against the flesh-eating bacteria. So every time we get into the ocean, we find something new and different and interesting. This vehicle is a 6,000 meter rated system that we built for University of Hawaii. It is a multi-mission platform that can carry all kinds of tools and sensors and equipment, and we've done everything from recovering a lost helicopter to going down and trying to get scientific investigation of the Clarion-Clipperton Ridge Zone where deep-sea mining is being contemplated, to try to give some better understanding of what is living there and what will be lost if deep-sea mining proceeds. And here's another shot of our great maker spaces we have here in Alameda. We're in one of the big hangars, Building 41 across from the Almanac. You're all welcome to come through and have a look. We have one of the grunt contingent works for us. It started as an intern. These two better show up at some point. And then we've got a number of others, including Chase, that have been through there. And this is where we take standard sea containers and we turn them into really interesting control vans. So here's that big 6,000 meter system in Hawaii. And you can see all the different screens in here, the monitors, where we have all the real-time information that comes up from the vehicle. So this is an area where you could really be looking at doing some machine learning, some other kinds of coding and things like that to make the information that these vehicles are capable of bringing up, terabytes of information per dive, and how do you manage and deal with all that data and make it useful to the broadest cut of scientists. This is a smaller vehicle that is used for investigating primarily archaeological sites. This one has been used looking and hunting for lost World War II submarines to help bring closure to families that lost loved ones on those wrecks. So it's called the Lost 42 Project. And this is one of our manipulator arms, fully made here in Alameda. It goes to full ocean depth. It's been used on our own remotely operated vehicles, and it also went to the deepest part of the sea on Jim Cameron's full ocean depth manned submersible. And in his case, he put a Rolex watch on the wrist of it. But it has full wrist rotation and all kinds of cool end effectors that we can put on it, so we can take core samples, push cores. We can snap off a piece of in situ rock for the geologists. They're really excited about things like that. And we can cut cables with it, do all kinds of work underwater. And this guy is a kind of a really crazy vehicle. We had a group of scientists that came to us one time and said, we want to be able to investigate the area underneath the Antarctic ice shelf, the part that hangs out over the ocean. But the problem was that the ice shelf in that location is 1,000 meters thick, and they could only make a hole that was 22 inches in diameter. So they would melt a hole 1,000 meters down, 3,300 feet, and we had to build this vehicle that would fit down the borehole when it's folded up. This is it in the open position. So when it collapses, where you see the part that says tether attachment point, if you pull up on that tether attachment point, then the whole thing kind of folds together like a very long pencil, and then it goes down the ice hole, opens up like this underneath the Antarctic ice shelf, and carries about 27 different sensors on board to be able to investigate that region that no one had been to before. It can also be used as a communication point for autonomous vehicles that typically get lost underneath the ice. This guy can help them find their way to the ice hole and then back out to the waiting ship. And here it is up in Lake Tahoe being tested. Lake Tahoe is one of these areas that we're trying to figure out how to get maximum bang for the buck with this vehicle. So we collaborated with University of Nevada, Reno, and the Davis, and USGS, and the Seismic Safety Commission. And so while we were testing this vehicle, we were also investigating the 5 different earthquake faults that transect Lake Tahoe. So they're afraid of another lake tsunami happening there in due course. And here's that big vehicle in Hawaii again. And you can see at the bottom of it, it has a big collection drawer and the big arms that are on board there. On this one, we were doing a recovery of a lost helicopter. And so here's these deep sea nodules that is getting a lot of press of late. So each one of these little nodules just starts off kind of around a biological item. Here there's some fossilized shark teeth. You can see them kind of forming around. And they're really truly millions of years old by the time they get to the size of a potato. But the deep sea bed is such a difficult environment to work in, and these are actually living nodules. They form, they're like bacteria that precipitate the rare earth minerals directly from the seawater and lay them down over these biological kernels. So it's really like the ocean kind of producing its own pearls, if you will. So it'd just be a horrific thing to contemplate, just tearing them up so we can have more smartphones or electric cars. When we really should be mining and sustainably using and reusing all of the minerals that we've collected from the environment all these many years. We also get involved in projects where people are actually living underwater. This is the last of the human-occupied habitats. It's based down in Key Largo, Florida. There's a couple of projects we're involved in now where people are looking at revisiting this whole idea of subsea habitats. So one of Jacques Cousteau's grandsons is working on a project called Proteus. There's a few other ones that are working on more portable underwater laboratories where people can actually get to know the animals in the deep sea by directly living with them for a couple of weeks at a time. We also get involved in the arts. This is a project called the Underwater Pavilions by the artist Doug Aitken. And he's done a lot of these kind of big sculptural projects, but he wanted to do one underwater, and he had no idea how to anchor these sculptures. So we took these down to Catalina Island, and there were 3 or 4 of these big forms that we put into the water. Some sides were mirrored, some sides were textured, and it was really interesting to not only have scuba divers interact with them, but see how the animals reacted to them. So we had sea lions kind of, barrel rolling through and kind of looking at themselves in the mirror. We had our state fish, the Garibaldi, trying to attack themselves in the mirrored surfaces. But one of the most interesting things that happened is that a lot of small nudibranchs from the area started to settle on and kind of make a home out of these pavilions. So when it came time to take them out, we could only get a permit for a number of months. The diving community all came together and they meticulously moved every single animal off the pavilions and saved them all. And these are now going to be probably reinstalled. They're thinking to put them in the Maldives, where they'll have a more tropical environment to experiment with. But this is really what we love to build at DOER. It's a human-occupied submersible. So these really give people the gift of time below the water. And here's a couple of them in our old workshop at Alameda Marina. These are the ones that you probably saw during the BBC Blue Planet 2 films. So we built the camera housings and we refurbished these 2 submersibles that were being used in those films. There's this little guy, the Deep Rover. It's really a really nice, solid film platform. And we get involved in other submersibles too. These are the Pisces submersibles, again at University of Hawaii. And I had the opportunity to dive these with some high school kids. Some of them had come from inner city Washington, D.C. They'd been involved in gangs. One guy had his brother shot and killed, and the chief of police there really liked this kid and kind of said, get him in this program. So we took him down in the sub, and he was horribly seasick on the boat, but we got him in the submersible, and he got in there, and he just couldn't stop talking about all the different blues that he experienced on the way down. And then he was able to observe the deep water Hawaiian stingray would come in and be attracted by the lights of the submersible, and it would come in and just lay in wait on the sandy bottom, and then it would kind of lift up its nose a little bit, and the small fish would go hide in the cave. And he was just snapping them up. And the ichthyologist on board said he had never really noticed that behavior before, but having that fresh set of eyes, he was able to document this brand new behavior. So it was a really worthwhile trip. And when I was down in that same submersible, I took this picture on my iPhone out the port, and it just shows you that kind of really rich diversity of life that's down there that we really know very little about. These are some of the submersibles we're building right now. These are 3-person vehicles. These are going to be deployed in French Polynesia at a island called Tetiaroa, and they'll be used for a combination of both science and tourism. So it's kind of a sustainable model where they can host some tours there to help pay for the operational costs, but the real job of these vehicles is to be dedicated to this one region where they can really kind of figure out what's going on below diver depth throughout French Polynesia. And so any of you guys kind of looking at college careers, the University of California has a research lab on Moorea, which is just, within a short hop from Tetiaroa. So they have a lot of different universities that collaborate with there. So there are going to be some really interesting opportunities to go deep. Here's another view of it. It kind of shows you 3 people in there. So these are currently under build, and again, as they come along, I encourage you guys to come by and have a look at them being completed. This is the big central frame that another one, 5-passenger one that we're building right now, getting ready to finish up. So you can see that there's a lot of, making that goes into these things, designing them, trying to figure out what materials to use for their harsh environment, and then really making them manufacturable. We see a lot of engineers that come through school and they have no idea about how they're actually going to make a part in a logical, repeatable way. So this one, as you can see, it's all kind of got different areas where it's bolted together. So for this particular design, we had to create it so that we were able to control the making of every single part on it, except for the sphere, which we have to have made elsewhere. But the things that we can make ourselves, we have to make them so they can be built on the machines that we have and be, repeatable task. So this is the making of the sphere itself. This is a big acrylic sphere. They're, cast, centrifuged, heat treated, machined. It's like a 6-month process just to make one of these spheres. But there it is. Nice, clear, beautiful, optically correct sphere. And this one will hold, as I said, 5 people and be able to take them for direct exploration of the ocean. We also have recently opened a nice public-facing dive center. So I encourage any of you all are old enough to learn how to dive. So if you'd like to come through and learn about direct ocean exploration, we're happy to help out and get everybody, we live on an island, we should be able to explore our waters. We're also closely involved with a number of nonprofits, the biggest one being Mission Blue. Mission Blue is kind of started in the Bay Area, and now each one of these little blue dots represents a Mission Blue hope spot. So they're all around the planet. And again, abundant opportunities for people that want to get into, oceanographic research, science, communications, just finding ways and means to share all the data across these spaces is a really big problem and critically urgent to figure out what's going on with ocean chemistry and change in the climate and the oceans. And the San Francisco Bay is a hope spot. This is Sylvia Gibson on one side, and then Karina, I can't remember her last name, from the Romberg Center. She's since moved on to University of Oregon, but Sylvia Gibson lives right here in Alameda, and she was the Hope Spot champion that put in the application for the Hope Spot here. And she hosts every second Saturday of the month. She's out hosting a beach cleanup, so tomorrow will be the second Saturday. Anybody wants to come out? She does a great job in helping clean up the area around the Seaplane Lagoon. And we found some amazing, weird stuff out there. You can't make some of that stuff up. But, it's really important that we really think about, what's going on with sea level rise, climate change, the ocean in general. And it starts on the shore. It's not just the deep ocean we need to be concerned about. You can kind of see the retreat of the shoreline and the erosion and things that we're facing right now. And some of the animals that are at risk as well here in the bay. But there's things we can do about it. I'm looking at your 3D printing stuff here, and a lot of these structures you see in this image are made with 3D printing of concrete or casting of concrete, and they're making structures to help support our native oysters, which are a really important animal to bring back to the bay. They used to be so abundant that Jack London, who is based right here in the Bay Area, he used to go out and poach oysters right here in Alameda. It used to be called Oyster Island because they were so abundant. But then during the gold rush with the hydro mining and so forth, the great silt infilled in the bay, and they were virtually wiped out. So by bringing these guys back and bringing the related eelgrass back, we're able to help make the shoreline much more resilient and really restore biodiversity to the bay. And clean up the water so we really have a swimmable bay, which would be really nice since we don't have enough swimming pools. Here we are at Point Molate, just across the bay. You can see the eelgrass is really doing well here. And we're striving to work with the Rongberg Center over at Tiburon to replant some of the eelgrass in Seaplane Lagoon as well. So that should be a really cool place to come out. I'm always thrilled when I go out there and I can see a little leopard shark or a bat ray going by, because the water quality is gradually improving. And some of these guys that we really enjoy seeing, are little native cormorants and pelicans, nudibranchs. This guy was actually right off the rock wall out here. And these guys too, they really do blend in. And jellies in the bay. So there's lots of reasons to get out there and explore the waters that surround us, and to really think about ways as makers that we can do a better job of taking care of the environment, and what we can do to really restore, starting on the land, yard by yard. There's many things that we can do as consumers and students and just in our everyday lives to make a really enduring difference, so we have a hospitable planet for the future. Even this little guy's out in the bay. We never really think about them, but these little guys are there. And of course our filter feeders. So it's true cause for hope, and I'm just so happy to be able to present to you guys, and I really do applaud you for all of your creativity and come around and learn more information about what you're doing, because I'm just really excited to see where you're going to be, what you're going to do. And thank you so much.
And as a small token of our appreciation to Liz, we have one of our custom T-shirts to give her.
Oh, beautiful. Thank you.
No problem. Thank you so much.
I brought a couple of books from the school library, so turn those over to one of the teachers.
Great.
Thank you.
Thank you so much, Liz.
You're welcome.
All right, a few more things before we go back into kind of just open Maker Faire time. I want to first recognize all of the officers who have made STEAM so great this year. So first up, our two seniors graduating this year. We have Christian, our vice president. Come up and stand over here. Lila, our secretary of projects. Maddie, our secretary of meetings. Isabella, our treasurer. And last but certainly not least, Matthew, our marketing and social media manager. So, thank you guys so much. It's been a great year, and I'm very proud of everything that we've done together.
Can we get a round of applause for Chase for organizing this whole thing? Well, Mr. McGee was gone. He couldn't be here today, but Chase stepped in and organized for this whole thing. So let's get a round of applause.
Okay, so this is our kind of opening page. I was the UI designer and team leader.
Yeah, I was in charge of most of the coding and art assets, although my brother Dane also did some of the art and was in charge of a lot of the game design.
Yeah, I did the gameplay design and some coding and sound effects too. And Dane, who's not here, also did a lot of the art and coding.
So our pitch is that last one is a 2D top-down action survival game that you can play in your browser. Delve into the heart of an ancient temple to discover what little remains of humanity.
I can talk about a little bit of the background. So this project has been in the works for about 2 to 3 months. All four of us have had background in the Unity game engine that we use for this project. And specifically, I probably had the most coding background, which is why I did a lot of the coding for this project, and it was in the C# language. Our main program software for this project was the Unity game engine, which is a super popular game engine, especially for 2D games. And so for the art, for pixel art, I like using Piskel, which is just an online website you can go to and create pixel art animations really easily. And then we use Visual Studio Code to do all of the programming, and GitHub is where we use shared all of our files to be able to collaborate on this project. All the art and animations for this project were all handmade, custom by myself and my brother Dane in Piscal. So yeah, you can see on the presentation a little bit of the process we went through, going different frames and then frame by frame adding in the different pixels and everything.
So I want to talk about management and source control real fast. It took a lot of tries to figure out our source control. We had a ton of issues with that. We started with Plastic SCM, which is a version control of MyUnity. They want you to basically buy their product in order to use it. We switched over to GitHub eventually so that we could have all of our team members collaborating. We used a whole bunch of design documents. We have a thing called the Scrum Sheet. That was where we all put in what we did for that day. We used Trello to manage our tasks, and we had a bunch of meetings all the time to discuss our plans. This is a UI concept for the main menu. We also concepted the art assets for the game. Our characters are fully top-down, as you might notice, and while the tile set and the environment has a slightly different perspective, it has dimension to it.
This is very early concept for the game.
Yeah.
This project incorporates procedurally generated random dungeon environment. So we have a lot of different features, such as the rooms, the enemies in the rooms, all the items, and even like environmental features like traps and pools of water, which are all procedurally generated, which was pretty difficult to keep track of it all, but I think it turned out really great. And you can see I used a little bit of help from ChatGPT for the more complex algorithms, but other than that, it was all made by from scratch.
So conceptually the gameplay involves the player running through a dungeon full of zombies, ghouls, and other stuff, and you collect ammo and grenades and level up while you go along and progress and get stronger to more easily defeat the enemies in the dungeon. And then you eventually find an entrance that is randomly located in the map that is the layer of the boss. You can find the slideshow and play the demo yourself.
Yeah, that's some art of our character.
Yeah, it's our main character.
Hello and welcome to the Anteater game by Micah, Richard, Ari, and Caden. So, what is the Anteater game, basically? The Anteater game is an ironic board game based off of Chutes and Ladders, Monopoly, Sorry, and other games such like that, like Candyland. Okay? So the player's objective is to, get to the end, which you can see here is the end. But you have to roll specifically on the end or else you restart. But that's not the only hindrance you really have. Each roll, you also choose and pick up a card. These cards are can be really good or really bad. Let's get to a card, hold on. These cards can either let you move in 4 spaces or move you back 4 spaces. Move you up 2 or send you straight to the Anteater Pit. So what is the Anteater Pit? It's like our flagship item. So the Anteater Pit's like the Monopoly jail. If you pick a card, you get sent to it. Okay? Get sent to the Anteater Pit, you have to roll special dice to get you out. And after rolling that special dice, you're moved back to where you originally were before going into the pit. During the pit, your other opponents have more of a chance to win because you can't really do anything but roll out. Okay? And then we also have these items called the glasses. These glasses are like a wild card. You can roll any dice from 1 to 6 using these glasses. So meaning if you get the glass card, which this is the glasses card. If you get the glasses card, if you're 5 spaces away, you can specifically move to 5 spaces. You gotta choose your next roll with the glasses. Only up to 6. So far my family's actually played it. Me, my younger brother, and my younger sister all enjoyed the game. We thought it was fun. Sadly, we don't have the board right now because the board was kind of messed up, so we were trying to make a new one, but we didn't have enough time. And the cards, they just wouldn't end up printing because the old ones just got they were paper. So we'd rather have professional stuff, but we didn't have the necessary items to actually bring them in here today.
Hello, my name is Martin. My name's Bice.
And this is our project, Cellbell.
So basically what our project is we've taken an old 20th century old school telephone and we've kind of repurposed it, redesigned it into more like a fun little walkie-talkie toy. So how it works is you call this number from any phone and you pick up and so you can talk into your phone and hear through your phone, and this is the receiving end. So you can call, this has its own number, you can call it, and yeah, you use it like a normal phone. And it's cool, you can keep it hooked up. Right now, at this point in time, we have it on a stand, supported through wood, but we can mount it on a wall, but we wanted to keep it portable for now because, it's good to have it moving around and just being portable for now.
Yeah, and at first we came up with a lot of different ways to really make the telephone. One way was do complete restoration of the parts, such as replacing all the old magnetic charges and all the wiring. That would have been complicated. So we decided to substitute with modern materials, such as using Raspberry Pi, and we really made it workable using Raspberry Pi and using Bluetooth. Yeah, so some of the equipment that we use is the caliper ruler to make sure we have the right measurements, drills, nails, screwdrivers to make sure to remove all the vintage items that was pretty much from the 1900s. And yeah, all the equipments are there. The main materials that we use is Raspberry Pi 3 that was provided by the school of Mr. McKee. We use the budget speaker, budget microphone, wireless, and USB adapter to make sure it's connected to wiring.
Here are some photos, some early designs. You can see over here, we have some early designs of the microphone before we kind of redesigned it. Some early pictures of the inside of the box. Originally, it was really dusty. What? Yeah. So these are some of the older parts that we had earlier. So they, old, rusty metal parts that don't really serve any purpose. They, maybe 100 years ago they served a purpose. But now, not so much. So what we've done is we kind of tore all the stuff we didn't need out, repurposed what we did need, used the casing, and put in a bunch of newer technology like the Raspberry Pi that Martin mentioned earlier. That's essentially what we did for the parts, and you can see that through the photos. But a big part was the listening device right here that you can see here, because that was it was just a mess. So we had to completely revamp it, take everything out, put all new stuff back in while trying to keep the case, because it wouldn't really be right if we just replaced everything and then kept so it looked new. We got to make it look old while also working as if it's brand new. So I think that's one of the difficulties that we faced here, but I think we made it work.
And I'm not sure if we're going to be talking about our roles, but I was the project manager / coding, so I worked with the Raspberry Pi and make sure our team was working pretty well with each other.
I was the product owner. I basically, I oversaw the design of the project, okay, what parts do we need to order? When does this need to, get done? How is this going to impact people? How are we going to present this? Just essentially, what are we going to do to make this product what it needs to be for the public eye? I took care of the parts, putting them in, repurposing, made the stand, helped with the number. Martin did most of the coding, but other than that, I feel like I worked on the physical design of the project. So all the physical aspects, I would say, I contributed to heavily.
Okay, and some of the takeaways that we got from the project is that it's important to have effective communication and work efficiency, because it's important to just make sure everybody's on task and make sure that everybody knows what they're going to be doing for the day. And another goal is that it's always important to give the right task to the right person, because everybody has different skill sets and abilities that they have, and it's important to really cater to that.
I also think a really big takeaway is that just in general, there's a lot of moving parts in this, technicalities that we weren't really aware of before. So I think a big difficulty that we faced was trying to take these things that we know nothing about and incorporate it into our design. So learn about it and then incorporate it. So it was difficult, but I'm really glad because I think we both did that in some sort of way. So yeah, in general, that's our project. Thank you. Say thanks.
Thank you.
So for our group project, we decided to make a bow
using the 3D printer. So basically a description. Me, Isabella, and I were basically inspired by this competition we did earlier in the semester, where we basically used foil and stuff like that to construct this. And that made us wonder whether or not we could create our own, and then also add little accessories as well. We also would further elaborate on this by creating code and prizes that relate to the theme of the boat. So in terms of group tasks, both of us kind of served as a manager for each other, basically making sure we're all on task and stuff. Isabella was most responsible for 3D printing the boat, creating prize stickers, and sketching everything, while I was most responsible for creating the accessories, the passengers, and then the code. So basically the equipment, programs, and materials that are necessary for this include Tinkercad, Prusa Slicer, filament, and then the actual 3D printer. So Tinkercad is how we used to design all of these. The Prusa Slicer was basically used to finalize and adjust stuff, make sure, add support systems for certain structures such as the boat and the passengers. The filament was the material utilized for this, and so on. Those are just some examples and links how to use Tinkercad in general, because I felt that was the most complex part of this project. So in terms of creating the passengers, I basically just use basic shapes to create more complex structures. So for example, I use spheres, rods, cones, stuff like that, and even just little hooks to create those complex structures. Those are just some more photos of the documentation process, creating the people. In addition to using those basic shapes, we also had to alter the dimensions of those. We had to convert from millimeters to inches with a half an inch by half an inch base with a 1.5 inch height. In terms of cargo or the initial design, I decided to scrap it because the rods were really hard to manipulate at first, and as a result, it was really hard to create an even face for each side of the cargo. In my newer design, I decided to not only pick a different shape to create it, which was not only more easier to manipulate, but I also added letters for the aesthetic, and So I created 2 of these, as you can see, and I changed the measurements once again from millimeters to inches, and I decided to do a 2x2 inch base with a 2.5 inch height. Once I was finished with these, I basically converted this to an STL file and sent it to Mr. McKee and Mr. Garling. However, if you want to do this on your own, you could send it to Prusa Slicer, add any forms of support to stabilize it, any final adjustments you want to make to the design, and then just send it to the 3D printer.
So I basically used the same materials as the cargo and stuff. And I found a simple boat design, and I manipulated it to what we wanted, so less complex shapes. And then I changed the size to 10 inches long, 4 inches wide, and 3 inches tall. And then I drew the actual boat size to see if the cargo and people would actually fit in the boat. And then, as Ryan said before, convert it into inches and export as an STL file and 3D print it with the help of Mr. McKee.
So for the next part of the project, we decided to create a little quiz, a trivia code thing revolving the theme of the boat and water in general, and just the project in general. Just Blue Jay is necessary. Those are just some examples and links how to. Initially, you just want to create the scanner class and then establish a main method. Scanner class basically allows for user input. Main method allows for things to print out properly. You want to create a new scanner object each time you want to hold a specific piece of data. I also created certain variables, specifically double or string data. Double holds decimal numbers. String data holds words and sentences.
And then I also decided to establish like if conditional statements. We noticed like there's some certain symbols here. So like the two lines in the beginning that looks like a pause sign, it stands for like an or statement. So either of those could be true before it evaluates the truth. The two equal signs is used to compare numbers. And then the dot equals operator is similar, except it's used to compare words to sentences. And then lastly, I created this print statement that congratulates you, and then like use like a little formula to calculate the final score of the individual. You need 4 or more to get right, to pass. Oh yeah, and once again, you have to compile and test the main method, and then finally there's some test results in the next slide. Yeah, those are just like some of my code testings and like just running it.
So if you pass the test, you get a sticker. So I created the stickers using Adobe Illustrator, Silhouette Studio, a printer, and then the die cut machine. And so I just used an example from my old project to create this new project. And I created a simple raindrop design using the pen tool, a shape tool, and then a gradient tool. I created a new layer for the outline of the sticker and changed the stroke of the side of the outline to be able to create. So I created separate artboards so I could export them as a separate file. And then I dragged them both into Silhouette Studios and set up the design setup and used the trace tool on the outline in order for the machine to cut around the sticker. And then I copied and pasted and aligned the stickers and cut line, and then just printed it using the Silhouette die cut machine.
And in conclusion, we found that our project was pretty successful as we were able to print the boat, all the accessories, and even go beyond that by creating like a little trivia quiz and like prizes around it, surrounding the theme of the boat, water, and like the overall project. So yeah.
The motor controller essentially is able to reverse the polarity of the current, so then the motor can move in different directions, and it can also control the speed. And then Arduinos like this one, it can be used to like interact with the controller, which reverses the polarity. So you can control the speed and the direction of motors, and then this is essentially just a motor, but it's in a bit of a different form, and it sort of moves this way instead of spinning. And okay. I mean, there's a motor in here, and it uses a screw to push it out. And these can be used for, doors and gates and cabinets and stuff. Like when you're trying to park your car in a driveway that has a gate, and you have a little remote in your car that opens the gate. Usually these are used to open the gate for you.
Can you use the Arduino?
Yeah, it uses the Arduino. The Arduino is telling the controller to reverse the polarity and controls the speed too, with built-in digital potentiometers.
This is our project computer friend. I am the project manager, and I worked in constructing and designing the head. Sunny was the product manager and also helped with constructing and designing the head.
And I was the project's lead programmer on this. I worked on doing the text-to-speech, controlling the Arduino and programming it, and interfacing with the motor inside the head.
So while Charlie worked on using the coding and programming the head, which he'll explain later, we found a website called InMove that published free instructions for how to design and 3D print a full-size robot. So we used that instruction to print out the head, and then we constructed the head and had to change some parts because we only wanted the jaw to move for the head. So we had to be creative with how we would connect the head to the neck, because in the instructions they actually had the neck having gears to turn the head, but we didn't want that. And so we connected a motor to the jaw, and we had a screw mechanism where when the motor turns, the screw will turn, and that will bring the jaw up and down.
My project is doing three main things with the programming. The first is when you type in a response, it is sending that to ChatGPT, and that is actually generating the response. The second thing it's doing is it is using Google's text-to-speech API to convert that into sound that is then played out of the speaker. And the final thing it is doing is it is interfacing with the Arduino. It is sending commands to it to turn the motor on and off. And then that, in turn, is moving the jaw up and down whenever it talks.
And then we get our final product, which is an animatronic head that takes text input from the user and speaks out ChatGPT's output.
Can you demo it? Yes, we can. Charlie?
Sure.
Right now, it's a setup that all you do is you type in your question for ChatGPT.
So let me type in, "Hi, how are you doing today?"
And
I'm doing
ChatGPT,
pretty well. Thanks for asking. How about you? How has your day been?
we're working on a text-to-speech to further improve it, make it sound more human-like. We're also trying to implement voice recognition, so you can just speak it to ChatGPT like you would with a regular person, and just improve the overall end usability.
And the jaw.
And the jaw. We're trying to get a better design mechanism for the jaw so it doesn't get caught up every 5 seconds.
Oh, that's our project. Thank you.
So for my Maker Faire project this year, I wanted to use the laser cutter to make a piece of art. And I started to see these light boxes all over my For You pages. So I decided I would try to make one. So for this, I would need Adobe Illustrator to trace out the design. And then I would obviously need the laser cutter to cut it out. And then I would need some sort of lighting device. Right here, I got a light from Mr. Fuoco, but I was originally planning on using LEDs for it. But there was some issues with the thickness of the paper. So I didn't really use any links or how-tos for this. I wanted to figure it out for myself. But I did use, I just watched some videos on YouTube of other people making it, but they weren't like how-tos, they were just like content videos. So I then chose the picture that I wanted to use. This is a picture that my mom took of me in the mountains. So I was like, that's cool, I'll try to do that. And then I designed it on Adobe Illustrator. I made 5 individual layers for each layer. This is what it looks like layered up. And then I cut out all the paper. I cut out all the paper on the laser cutter. And then I needed to make a box for it, and I was going to use wooden plywood for it. So I found this website where I can put in the dimensions of the box that I wanted, and then it would give me a file that I can cut out on the laser cutter. But the laser cutter broke when I wanted to print it out, so I wasn't able to actually use this box. And I had to make a cardboard frame instead and use this lighting device. So with this project, I learned more about how to use the laser cutter and how to use Adobe Illustrator even better. It's definitely still in its prototype stages because I want to use a fully wooden box and LEDs in the future. And to do that, I'll need to use some thinner paper. But this was mainly just a great learning experience for how to make projects like this in the future. And I can probably make more complicated ones now and make better ones in the future. I'm pretty happy with how it turned out, but still work in progress.
Well, this is my STEAM project that I've been working on for like the past couple months or so. That it's been a struggle to work with because of, buying the different pieces, building it, which took us some time. It's an RC drift car. The whole point of it is for it to drift. We can't, at the moment, it can't really run with what I got right now because of a couple of chip pins. The motor, the battery, the receiver, everything is connected. It is chargeable, so you can reuse it over and over again. So some of the components we have here is the motor, which I can't really run it, like I said earlier, because I did chip off one of the things here, which connects to the electricity and the battery, which if we try, it would just make this really weird noise of it not receiving what it needs to do. But we can turn it on, which is right here. The fans start going off. But like I said, it just goes off like that. It's a work in progress. Earlier, it was running perfectly fine. But here's the controller that we can move the wheels side to side. We can adjust the amount of how fast it would turn when it's actually driving around. But that's about it. The pins, the gears to move the wheels back and forth. I did try to do 3D printing, which on 360 it took some time to work on, but I never really got it done because the whole bodybuilding, the curves and everything on the car, I couldn't really figure it out myself, so I tried to get help from others, which it's been a problem too, but it's all a work in progress, so hopefully I get it done by next year. And yeah, that's about it.
Hello, this is my Pixar lamp. It is a recreation of the Pixar lamp. It's about 6 feet tall. It's made out of an umbrella base and then some PVC pipe, some nails, some wood. I built it for the junior class's Spirit Week, and now I'm going to put it into my room. You really messed up the head of the light. There we go. It can turn on, off, it can move up and down. I don't really know what to say about it. It was a fun project to build. I based it all off of one image online that I found of the lamp and took where they put their nails and put it there on mine, and any adaptations I needed to make, I made them. But yeah, I made it about I think it took about a week or so from getting all this stuff and then putting it together. But yeah, it was a fun project.
Hi, my name is Chase Vanderveer. This is
Jack Obot
and
Nicholas Perez.
And we are the team Rapid Capacitor Discharge Terminal, also known as RACT, for our 2023 Engineering Pathway project. So first off, we want to talk about our project goals and constraints. So first off, we wanted a box that improves safety in the process of disposing capacitors. So we want to make sure that everybody is safe when they're using electrical engineering components, and making sure that they're not using their capacitors, which it may otherwise be compromised and result in consumer electronic possibly injuries or also the product failing. So in order to fix this project, we wanted to ensure that it contained a manual interface that has our power, our arming, and our firing switches. It also needed an indicator light to signify power and the arming. That way you can see what step of the process you are in at all times.
All right, so your group members. So Chase Vanderveer, he was the project manager, and he's also in charge of assembly, and that also included, he paid for most of the parts, or the ones that we had to buy online. There's me, Jack Obot. I did all the CAD designs, all of the modeling online and stuff, and I also did the risk management, and then we have Nicholas Perez, and he did the materials and components procurement, so he went online and he found all of the materials that we need and found out what we have and also what we need to order. And then he also did the documentation, so he was in charge of photographing and writing everything down. All right, so our equipment and programs, we had the Dremel Digilab laser cutter, so we used that to cut out the box. We were originally going to use that as the base plate, but we didn't. We ended up using the current black cover that we have for it because it just looks better. We also used the soldering stations, and we used that to solder all of the electronics together inside the box. For programs, we used AutoCAD 2023, and that was for the modeling of the box. And then we also did SmartDraw, which we used to make a model of how we wanted all of the wiring done. And then KeyCAD, and that was for procurement.
All right, yeah, so for the materials, we needed things like the arming lights, power switches, fire switches, arming keys, the ABS sheets you can see here, and obviously the box. And so we got those from Amazon and DigiKey, and that was sort of my job, was to make sure that all the parts fit together and that they worked in the way that we needed them to work.
Button struggle?
So the button struggle we had we needed a button that could basically hold the capacity of the outlet. It needed to be 120 volts and needed to be 25 amps, I believe. 15 amps. And so there weren't a lot of buttons that could have that sort of parameters while also fitting inside our box. So that was basically my job. Then so here we have some photo documentation of sort of the process that we went through. Sort of after we got all the materials, we sort of wired it all up. That was Chase's job. And then we had to do a bunch of testings to make sure that first it works and then it's also safe.
So over here we have our box. It's currently plugged in to the outlet. We also have it on a power strip for a fuse. All right, Jack, go ahead and turn on the power. So this signifies that we have 2 red lights and that we are ready to arm. At this point, we have a separate key, which will now be inserted by Nico, by a second person, to ensure that 2 people have to have permission in order to fire the capacitor. At this point, Nico will turn the key, and the box goes off. At this point, the safety procedure was not followed and the test fire button was not pressed down, but at this point we do have a successfully discharged capacitor.
Maker Faire 2023.
Number 4.
Lay down. Oh no, someone hold me.
I got you. Here you go. Get on my back. Ready?
Wait, Christian, lay down.
That's great.
Lay down on your side.
That's
like
great.
volleyball.
There you go. 1, 2, 3. What just happened?